Okay, so we're given one focal point, which means that this has got to be a mirror. It's a concave mirror because it's curved at the top and the bottom. So we'll draw our two lines. And as we remember, our first line comes in parallel, hits the mirror, and then we'll reflect. We'll change the color so that we can see which way it goes. It will reflect back through the focal point. Okay? Now the second line will come from the focal point to the tip. We'll go back to our original color here. And it will go from the focal point to the tip and then onto the mirror. And finally, it will reflect back out parallel to where the center line. So where these two green lines intersect is where the image is. So we're going to extend them back, and we'll do that by a dotted line. So if we extend this one back, go back to there, and if we extend this one out, it'll go back to there. And where those two green lines intersect, those two reflected lines intersect, is where the object is going to be, or the image is going to be. So let's change the image and make it white. I think that's white. And we will draw our image like that. Be a little larger than what we have here. We'll get that back up to there. So there's our image. And we can see that it's behind the mirror, which means it's going to be an imaginary image. So the nature of this thing is going to be imaginary. Now we have to find the location for everything. So we have two equations which we can use to find size and location. We already know that it's imaginary. So we have 1 over f equals 1 over p plus 1 over I, where f stands for the focal length, p stands for the object length, and I stands for the image location. So we have 1 over 10 equals 1 over 6 plus 1 over I. And we have to solve that for I. And if we do that, we will get I equals minus 15 centimeters. The negative tells me that it's imaginary, which we already knew, and that it's 15 centimeters behind the mirror. So there's our location, and our nature, and now we want to find the size, so we can use our second equation, which is I over O equals lowercase I over P. So the image size, which is what capital I stands for, over the object side, which is 3, equals I, which we just found, 15, divided by P, which was given as 6. Notice we don't have to worry about carrying the negative numbers through. We solve this for I, and we get 7.5 centimeters. And that's our second answer, numerical answer. So it's 7.5 vertically high. And we're done.